Hello and welcome to this demonstration of the AIMMS SC Navigator application. The goal of this demo is to provide you with high-level insights into the types of use cases and questions that could be addressed using this technology, as well as give you a look at the look and feel of the technology and how it enables ease of use and really powerful scenario modeling and decision-making within your organization. Businesses like Intel and BASF, to name a few, are using this technology to optimize their end-to-end global supply chains at either a strategic or a tactical level. So in order to bring the functionality of this application to life, I'll first introduce the fictional US-based business that we will be looking at and optimizing the footprint of. I'll then introduce the high-level questions that the tool addresses, the workflow that is used to address those questions, and how the app is systematically guiding you through the network design process, and then run a couple of meaningful scenarios that businesses typically would run using this tool. So you get a sense of not only the questions you would be able to address, but how you would approach answering them as well. In terms of the business that we'll look at, as I mentioned, this is a fictional US-based company that manufactures and distributes different types of liquids. So if we look at the products of the supply chain, we have certain formulas that are going through the network, as well as certain raw materials. All of the data for this tool, just by the way, has already been modeled in the background. You have a couple approaches. One is using an Excel template to feed the data into the tool, or directly connecting our application with whatever ERP system you may be using. You would also notice, by the way, that the tool is entirely cloud-based, and all the functionalities of the tool are accessible simply by using a cloud environment specific to your business. Now, if we evaluate this business a little bit, we'll notice that there are some suppliers in this network, some of finished goods denoted by the FG, and some maybe of raw materials denoted by the RM. If we continue going through the network, we'll notice that these suppliers have the ability to send products to certain production facilities where a bill of material process takes place and converts them into finished goods. So for instance, there's a production facility here in Atlanta, which can take certain raw materials and create these flavors out of it. From the production facilities, the product can go to certain CDCs, centrally located DCs, with high fixed cost, high capacities. From there, it can go to various LDCs, local DCs, which may have lower capacities and costs and are much closer to your final customer points. And then finally, about 300 unique customers that the product ends up at. A couple of things already to keep in mind. Everything that you see in the map is entirely customizable. So the shapes, sizes, colors, icons can look and be represented exactly what is in a way that is relevant to your business, simply by going here and customizing the map. Now, as we saw, there are already some flows in this map, which represents to us the as-is network of this business. So the baseline network, we've already modeled that. So now the idea becomes answering a few high-level questions for this business. Firstly, what is the optimal size of each of these nodes in the business? And by size, I mean, what is the optimal capacity and throughput and usage of each of these facilities? Whether that is your supplier, your production, your warehousing, your cross docks, whatever that node might represent. What is the optimal location that each of these nodes should be placed in? And what is the optimal flow that should occur through my network? So what is the best way of sourcing the product, moving it internally, and moving it to the customer as well? You would also notice that there is no limit in the tool in terms of the echelons that you design. In this case, we have supplier, production, CDC, LDC, customer, but there could be 10 different echelons in the middle before the product ends up at your final customer point. Now, as I mentioned, the whole idea is as you answer these three overarching questions, there are thousands and thousands of potential scenarios you might want to run. The tool enables you to run those scenarios in a very easy and intuitive way. So you'll notice on the left-hand side, there is a workflow that is systematically guiding you through the network design process. In this workflow, in the first phase, you get access to all of your input data so that you can play with that data in different meaningful ways and configure different types of scenarios. And we'll do that in a second as well. Then in the control panel, you can you can pick the conditions under which your scenario behaves. So for instance, if we change the demand of a customer in the data section, do we want that demand increase to act under conditions where our capacities of the warehouses can be exceeded, or do we want to work within the existing capacities? Do we want to optimize for cost, or do we want to optimize for profit? So all of these conditions can be set in the control panel. Then in the third phase of the tool, you get firstly this high level insight into what the scenario represents, in this case, the baseline scenario. But then you get all of the details into the results as well. So what is exactly happening at our suppliers? What does our procurement look like? What is our warehousing behavior, our transportation, our customer fulfillment and lead times? All the detailed insights come to life. And then finally, in the fourth phase of the tool, if there are certain sets of scenarios that you as a business are going to keep repeating over and over, you can pre-save them into the system and run them against your data each and every time. You could also use this section to run batch scenarios. So if you have 100 scenarios you want to run at the same time, it's entirely possible to do that in the scenario section. So over the period of this demo, we will walk through these different sections, and I'll run a couple of meaningful scenarios to help you understand how the tool works. One other important consideration before we go ahead and run our first scenario is to consider the fact that as we optimize this network in this application, we can optimize it to meet any objective a business may have. So that's not only optimizing for cost, minimizing cost, or maximizing profit. That could be minimizing our carbon footprint, or minimizing our supplier risk, minimizing the waste that's in our network. Each of those scenarios could represent different footprints. And the whole idea is that the tool allows you to play with those different trade-offs and find the happy balance where all the stakeholders of a business are satisfied. You would also notice in this results page, as well as every other page of the app, there is a KPI summary at the bottom. So we could see for the baseline network, we are reaching a certain end-to-end cost. There's a certain profit. There's the details of our cost breakdown, and details in terms of carbon emission, inventory holding, taxes as well. This is all entirely customizable, and for the user, any objective that they may have can be added into the tool. So now let's go ahead and run our first scenario. Let's assume for this business, there is an uncertainty, a what-if scenario, that next year, the demand for our retail customers, specifically for one of our products, let's say Formula A, is going to increase by 20%. So you can imagine that's quite a detailed scenario, but the tool allows you to run that in a very intuitive way. For instance, if we go in the data section, firstly, we get a high-level insight into what our model represents, how many products we're looking at, how many periods. This, by the way, is a multi-period model where we have modeled 2 separate periods, half one of the year, half 2 of the year as well. The different types of transportation we have available, customers, and so on. But for our scenario, what we want to do is increase the demand of one of our customer segments, which is retail. So I'll go ahead in the customer and select our retail customers for one of the products, which is Formula A. So now all the demand for Formula A for retail customers has come to life here based on our input data. The reason I was able to do this very quickly by using this grouping is a logic that applies throughout this technology, where you can create groupings of your customers, products, locations, suppliers, whatever it might be, and leverage those groupings to construct and run detailed scenarios in a similar way as I just showed you here. Now let's assume the demand for this selection, retail Formula A, is going to increase by 20%. This change has now been accounted for in the application. We can go ahead and run the optimize button already, but let's now go into the control panel and set the conditions under which this scenario can behave. So you'll notice there's a lot of options that you have here. All of your constraints in the tool you have access to, and you could either enforce them or relax them as a result of your scenario. So for the next scenario, let's go ahead and relax our warehousing capacities and production capacities. What this means is that once we hit the optimize button in the tool, we would be able to understand if our demand were to increase by 20% for this particular segment and product, and we were allowed to exceed the capacities we had, both the minimum and maximum capacities at our production and warehousing sites, what is the minimum cost network that we could get to? You would notice also that you could very easily switch your objective to maximizing revenue, maximizing profit. And as you will see later on, you could also start including carbon emissions, taxes, any objective you might have into the optimization engine as well. So now let's go ahead and hit the optimize button. What happens is all of your data that's been stored on an online database gets engaged. The optimization engine and the code that powers this application is all written in the AIMMS modeling language, but all of that is hidden from the end user. What you get in the front end is an intuitive user interface that you can leverage to very quickly run different types of scenarios. And you will notice that even for very complex types of scenarios, solutions typically solve within a matter of seconds. In this page, while the solution runs, you would also notice you could pick which products you want to run the scenario for, how many nodes you want as a result of your scenario in the min-max constraint, as well as if you want to pick certain locations, particularly to be opened or closed in your network, you have ability to do that using this open close section as well. So really there's tremendous amount of functionality and feature that's contained within this page. And it's just a matter of checking the right boxes and buttons to run these detailed scenarios as well. So what's happened is the scenario ran. And now if I go back into the results section, we'll notice that on the right-hand side, we have the baseline scenario, the first scenario that we ran, and I showed you, and now the latest active scenario shown to you side by side. The reason being that now it becomes easy for us to first visually understand how some of our flows and behavior of nodes may have changed. So first, let me go ahead and reselect all our filters so we get the full picture. And then we'll quickly evaluate what has changed in these two scenarios. So firstly, you may start noticing that some of the customer delivery might be done slightly differently in these two scenarios. What we could also do is leverage these filters over here and the view options to get different insights into these two maps. So for instance, if I turn on status coloring, the tool immediately highlights for us the different in behavior in the two maps, in the two scenarios. Or we could turn on load coloring, and the tool immediately highlights the demand distribution of each of our customers as well. So all of these high-level insights you could very quickly start gauging and comparing by using this page of the tool. I'm not going in too much detail into each one of the visualizations and outputs, but please keep in mind that we could, if you are interested, a much more deeper in-depth demo can be scheduled for your needs as well. You will also notice that in every output page, there is something called the period selector. What the period selector allows you to do is go between the different periods of your model. So as I mentioned in this case, this is a multi-period model where we have modeled half one of the year and half two. So if I go into the second half of the year, you might start noticing that the behavior, and I'll just make this full screen, the behavior of some of your flows significantly changes. So these three lanes did not exist in half one, but they exist in half two. Essentially, the tool is saying that the way in which you should serve your market in half two of the year should be different than half one, considering the fact that your demand may be different, your capacities may be different in the different periods as well. If I go back to half one, you will start noticing once again, let's just give it a second, that the behavior and some of the usage of the nodes starts changing as well. So let's go ahead and run a second scenario now, and I will make this scenario very overarching just for the sake of showing the functionality of the tool, and then we'll go ahead and on a high level, see all the different outputs that the tool provides to us as well. So firstly, let's go ahead and allow or relax the min-max constraint for our warehouses and production as well. What this means is that the tool will now be able to open and close as many locations as it sees fit. As you would notice, previously, we had a scenario condition where 31 warehouses as a min and max had to be open. So the tool had a constraint to open exactly 31 locations. By relaxing this, the tool is now able to open and close as it sees fit. At the same time, all the different nodes that we have in the network, we have the ability to either force some of them to remain open or closed in our scenario. So what you'll notice is for the first few scenarios, we had certain center of gravity locations, some greenfield locations that we had brought into the tool. What I'd like to do now is allow these locations, which were previously forced closed, to become part of the mix. Essentially, the tool has the ability to use these COG nodes if it thinks that it's valuable and cost optimal for us to do so. These COG nodes, by the way, were brought into the tool using our center of gravity application. It's seamlessly integrated with the SC Navigator app that we're looking at. For the sake of time, we won't cover the COG app in this demo, but once again, a detailed demo can be set up for you for that as well. You'll notice as the solution runs, for larger models that may take slightly longer to solve, you also have this feature in the tool to set a certain time limit, meaning you could tell the app to solve within 1 minute, and essentially the tool will tell you how far away from the truly optimal answer are you within that 1 minute of solve. So then you can start readjusting not only the size of your model, but also save yourself a lot of time by not waiting, multiple minutes for a solve, where within 1 minute, you might actually be getting very close to the truly optimal answer as well. So this scenario ran as well. The logic of the app would remain exactly the same, where we can go into the results section and immediately start noticing that, well, the behavior of our nodes is very different now. In the previous two comparison scenarios, it wasn't drastically different, but now it's changing significantly because we've allowed certain nodes to be closed. So for instance, all of these journeys are now occurring, some really far journeys as well, because clearly the tool would have chosen to close down certain locations and maybe incur a higher transportation cost, but a much lower fixed cost of keeping our nodes open as well. So if we look at some of the outputs on a high level now, the warehouse production and supply reports work in similar ways. So I'll use the warehouse report as an example. Firstly, we get a high level map representing the health and behavior of our nodes. So every node in black is closed, in red is overutilized, and in yellow is running at maximum capacity. Now this chart over here, which is showing us half two information, let me switch back to half one, also shows us the behavior in this particular period of every single warehouse in our supply chain, together with how much overcapacity you may be going. And finally, you have this visualization showing you the details for all periods at the same time. By clicking a certain facility here, the chart on the right then updates to show us further information in terms of the throughput through that warehouse as well. You'll also notice in every single page, you have filters which allow you to visualize just the information that you care about. You have the period selector, which allows you to show how the behavior of your nodes is different in the different periods. as well as detailed drill down outputs. So if I scroll down, we start noticing all of the outputs of all our warehouses, their usage per product, our inventory outputs by product, our stock progression. All this detail is shown to us as well. And you as a user have the option to either download these files as Excel files for any further data validation, or in fact, you could download the end-to-end solution as well, so that you could do any further data validation or visualization out of it. In fact, you could connect the outputs of our tool to your own visualization dashboard, such as Tableau or Power BI, so that your own internal visualizations are also updated every time you run a scenario. If we keep walking through some of the other outputs, the transport page gives us insight for how each of the modes of transport in our network are behaving, as well as all the individual journeys that should be made by our network in our network to be truly optimal. So for instance, the way to interpret this would be, we should use the inbound finished good truck mode of transport. By the way, all these modes completely user input dependent, so you can reflect your supply chain in the tool with no problem. You should use this mode to move the product from finished good supplier Memphis to the DC in Cordell. You should move Formula A 200,000 units. This is the distance covered, the cost incurred, and so on. The customer report gives us deeper insights into the fulfillment of our network. So how are we doing in terms of meeting our customer demand, as well as how we're doing in terms of meeting our lead time requirements. As I mentioned, each output page also has a detailed drill down included with it. The KPI overview provides high-level insights into all of the costs and revenue targets that we are achieving as a business in this scenario, and helps you ensure that no numbers that you see in the app are a black box. You can easily dive into where each of the outputs are coming from, simply by scrolling down, going into the relevant section, and understanding what are all the costs that we are incurring there. Now, there's a couple other very valuable output pages that I'd like to go through. Firstly, the cost to serve report, which helps us understand the detailed per unit breakdown of servicing any particular customer. So if we select Fargo as an example here, by clicking on this node on the map, you would notice that these tables are now dynamically updated. And by zooming in, we start noticing that in order to service Fargo with Formula C, it costs us about $18 per unit. Now that $18 per unit is broken up. 4.5 of that, or roughly 25%, is the supply variable cost. 25% is the primary transport cost. In other words, close to 50% of the cost of servicing this product to this customer is on the inbound leg. So then this cost to serve report starts highlighting maybe some pain points or pressure areas of your supply chain that might deserve further digging into. To build upon this idea, we also have an end-to-end report, which helps you understand the detailed end-to-end journey that every single product takes to service a customer demand. So we could select all customers at once here, but let's use Abilene as an example. So we'll notice in order for the product to reach Abilene, all of these nodes had to be engaged in some shape or form. So suppliers, production, warehouses, all the way to the customer. So visually, we get to understand how the product moved, but then we get further details and the step-by-step journey in this table below, where the tool tells us as a step 1, there was a supplier variable cost incurred where we procured our raw materials from these raw material suppliers, raw material Reno and raw material Stockton. The next step becomes moving it primary transport from the supplier to the production facility in Trenton. And if we follow the logic, step 5 becomes moving it from a DC in Denver, interestingly, the COG DC in Denver, to our cross dock in Dallas, finally from the Dallas cross dock to the Abilene customer. And this is particularly for Formula A. Now, the same logic applies for Formula B. So all the different products, all the combinations in order to satisfy a particular customer demand. So quite a powerful piece of functionality. which you could also download as a CSV file at the same time and connect to your dashboarding systems. So hopefully this is starting to give you a deeper sense, at least, into the functionalities of the tool. One other very key piece of thing to keep in mind is that all of the output pages in the tool can be populated with multiple scenario outputs at the same time, which means you could very easily and intuitively compare how things have shifted and changed between two scenarios. So that's entirely possible to do. Now, as a final quick scenario, I'd also like to help you understand the optimization options section of the tool, where you have control over which objectives you want to achieve as a business. For instance, so far, the scenarios we ran, we were considering cost, inventory holding, and taxes in the optimization. So the tool was actively trying to minimize each one of these costs. However, carbon emission was not part of the optimization. Of course, there's an impact on carbon once we optimize for cost, but the tool wasn't actively optimizing for carbon in itself. So what we can do now is switch the logic a little bit, where we run a scenario just to minimize the carbon in our network that's measured in tons. So these objectives don't necessarily have to be cost. They could be any unit of measure. Now we'll start noticing as we start to minimize carbon, right now we're incurring 1 million, this number might go down, right? But there might be a negative impact in our cost, which is now $186 million. And this is where the trade-offs come to life as well, because clearly if we want to minimize carbon and use the most efficient nodes in our supply chain, those efficient nodes may be more expensive than if we were just trying to minimize the cost. So let's give it 1 second and see what happens to our outputs once we run this type of a scenario. You'll notice we're getting quite close to a truly optimal answer. And what happens is that our carbon emission goes down by roughly 100,000 tons, but our physical cost has gone up over $100 million, which might not be very efficient overall, or may not be the ideal solution for all our stakeholders. So what you could start doing then is giving different constraints for your other objectives as well. So we could say minimize for carbon, but ensure that my physical cost of the network does not exceed 250 million. And by running these types of scenarios, considering different objectives, giving them different weights, you can really start finding the ideal balance ideal balanced footprint for your supply chain, where you're optimizing for whatever is relevant to your business to the relevant degrees as well. Now, as this model solves, I'd like to thank you for your time and joining me on this demo. You'll notice once the model solves that what the best carbon emissions we can do while ensuring our cost doesn't exceed 250 million. If you would like a more in-depth, more personalized demo for your business, please feel free to reach out to your AIMMS representative. We would be more than happy and willing to set up some time with you and help you understand in more detail the benefits that this app can help you achieve as a business. So with that being said, thank you once again for your time.